Diagnosing a Ghost Network issue on macOS, the automated Forge chapter. The ghost problem my Mac Mini had internet. It could ping Google. DNS was resolving, and yet nothing would load, not slow, not timing out with an error. Nothing. Pages would show the connecting animation, make initial contact, then stop. Completely. No error code, just silence. This is J-Family Mission Control, a Mac Mini M2 Pro running 3 automated YouTube pipelines. Every cron job, every Ollama API call, every YouTube upload depends on this machine having reliable network access. N8N workflows don't recover gracefully from a machine that can reach the internet but can't transfer data through it. Every other device on the network was working. Phones, laptops, tablets, all fine. Ubiquiti Wi-Fi network, everything connected, everything showing signal. Just this one Mac Mini refusing to actually move data. What followed was a 6-phase diagnostic that uncovered 3 simultaneous problems. Each one was real, each one masked the next. This is all of them in order with the exact commands that found them. Chapter, Phase 1, ruling out the obvious. Start with the network stack from the bottom up. Never assume a layer is broken before testing it. Ping 192, 168, 1 gateway responds immediately. LAN is fine. The machine is on the network, the switch or AP is forwarding frames, the gateway is reachable. Ping 8 Google's public DNS responds. Packets are leaving the machine, crossing the NAT boundary, hitting the internet and coming back. Routing is working. Ping Google. Com request timeout. Fails completely. 3 pings. The third one breaks. That isolates the entire problem to a single layer, DNS. The machine can reach the internet. It just can't resolve names. Gateway is fine. Route is fine. DNS is broken. This 3-command sequence is non-negotiable for any network diagnostic. Run them in this order. Each one eliminates a layer. Skip steps and you'll spend an hour troubleshooting the wrong thing. Chapter, Phase 2, the Pi-hole rabbit hole. This network uses Pi-hole for DNS filtering. Pi-hole runs on a Raspberry Pi at 192, 168, 237. It's the DNS server for every device on the network. Ping 192, 168, 237. Pi-hole responds. It's reachable over the LAN. The problem isn't that Pi-hole is offline. Dig Google. Com at 192, 168, 237. Timeout. No response. Pi-hole is up. The machine can reach it, but it's not answering DNS queries. Something is broken inside Pi-hole itself. Into the Pi-hole admin dashboard. Check settings. Right arrow DNS. Right arrow upstream DNS servers. Pi-hole was configured to use 127.0.0.1/5053. That's unbound. A local recursive DNS resolver running on the Pi itself, set up for private DNS resolution without sending queries to third-party servers. Unbound had crashed. It wasn't running. Pi-hole was trying to forward every query to a local service that didn't respond, so every query died. Fix, removed Unbound from the upstream list, added 8 directly as a temporary fallback. Restarted Pi-hole's FTL DNS resolver. Sudo service Pi-hole FTL restart. Pi-hole is now answering queries. Go back to the Mac, try again. Still broken. Chapter Phase 3, the reboot. Pi-hole's query log shows DNS queries arriving from every device on the network. From the Mac Mini, nothing, 0 queries. But Scuttle DNS on the Mac confirms the correct configuration. DNS configuration resolver #1 nameserver 0, 192, 168, 237. The Mac knows Pi-hole is the DNS server. It's just not sending queries to it. Something between the Mac and Pi-hole is eating UDP port 53 traffic, or the Mac's DNS client itself is in a broken state after the earlier failure. Dig Google. Com at 192, 168, 237. Still timing out from the Mac. Even with a direct DNS query to the Pi-hole IP, rebooted the Mac Mini. After reboot, ping Google. Com works. DNS resolves. Reboot cleared whatever state the DNS client was stuck in, but pages still won't fully load. They start, you can see the initial connection, then stall completely mid-transfer. The reboot appeared to fix DNS. It did not fix the machine. Chapter, Phase 4, Wi-Fi signal imbalance. Ping the gateway with a fast interval to look at latency patterns. Ping I0, 192, 168, 1 first few replies, 2 ms, 3 ms, 4 ms, normal, then 847 ms, then back to 3 ms, then 1133 ms, then 5 ms. That's not a DNS problem. That's a Wi-Fi stability problem. Specifically, the pattern of normal latency punctuated by multi-second spikes indicates signal asymmetry between the access point and the client. The Ubiquiti AP had transmit power set to high. This sounds like it should improve things, but it creates a specific failure mode. The AP broadcasts loudly. The Mac Mini hears it clearly and reports excellent signal strength, but the Mac Mini's built-in antenna can only broadcast at a fraction of that power. The AP can barely hear the client's responses. The client thinks the connection is strong. The AP disagrees. Packets get lost going one direction. Mac Mini has one of the weakest built-in Wi-Fi antennas in Apple's lineup. It's a known limitation of the form factor. Change the AP transmit power from high to auto in the Ubiquiti dashboard. Auto negotiates power levels based on what the client can actually handle. Pages became slightly more responsive. Not fixed, still stalling. Chapter Phase 5. The Studio account. Clue: this machine runs two user accounts, an admin account used for system management and the Studio account where all the production pipelines run under cron. Tested the admin account, internet works, pages load, YouTube, GitHub, everything. Switch to the Studio account, nothing loads, same network interface, same IP, same DNS, same gateway. One account works, the other doesn't. When two accounts on the same machine exhibit different behavior with identical network configuration, the problem is not the network. The problem is something running in user space, specifically something that initializes differently between the two sessions. In the Studio account, curl v https://google, com output, asterisk trying 142, 250, 80, 46, 443, asterisk connected to Google, com 142, 250, 80, 46, port 443, asterisk SSL connect, connection reset by peer, asterisk closing connection curl, 35 SSL connect, connection reset by peer, TCP connects, port 443 responds, the TLS handshake starts, then connection reset, plain HTTP connectivity works. HTTPS is being actively intercepted, and whatever is intercepting it is failing to complete the TLS handshake. This is not a network problem. This is a process on the machine killing TLS connections. Chapter Phase 6. Finding Avira connection reset by peer during a TLS handshake. While ping and HTTP both work, has one primary cause, a security product performing TLS inspection. ls/library/launch agent/ there it was, multiple com, Avira, asterisk entries. Avira Security was installed. PS aux grep I Avira's scanning service running as root via system extension. Active across all user accounts on the machine. Avira performs TLS inspection by acting as a local proxy for all HTTPS traffic. It intercepts the connection, decrypts the content, scans it for malware, re-encrypts, and forwards it. When it works, you never notice. When it's broken, and it was broken, it intercepts every HTTPS connection, fails to process it, and resets it. The Avira application itself would not open in either user account. The UI was gone. The system extension was running. It was intercepting every outbound TLS connection and dropping them. This is why it looked like a network problem for so long. ICMP ping, Avira doesn't touch it. UDP port 53 DNS, Avira doesn't inspect it. Plain HTTP passes through. Only HTTPS gets intercepted. Every diagnostic tool that uses plain connectivity reported everything working fine. Only actual application layer HTTPS traffic was dying. The per-account behavior difference. Studio account happened to trigger the broken Avira proxy in a way the admin session didn't, possibly a difference in how the system extension attached to each session, or a credential cache issue in the Avira service. Chapter The Fix. Step 1. Kill all Avira processes. Sudo pkill f Avira immediate test. Curl v https://google. Com in the Studio account. TLS handshake completes. Page loads. Step 2. Remove the system extension. System preferences right arrow privacy and security right arrow extensions right arrow find the Avira entry right arrow remove. This requires a restart prompt. Step 3. Remove the application and all launch entries. Sudo rm/applications/Avira. App sudo rmf/library/launch agent/com. Avira. Asterisk sudo rmf/library/launch daemon/com. Avira. Asterisk. Step 4. Reboot. After reboot, full internet access in both accounts. All HTTPS traffic flowing. N8 and health check passed. Ollama API responding. YouTube upload API working. All three pipeline crons ran clean that night. Secondary fixes locked in. Pi hole upstream permanently changed from unbound to 8 until unbound is restarted via SSH. Sudo systemtool restart unbound on the Pi. Ubiquiti AP transmit power staying on auto. Chapter Key lessons. DNS working does not mean the internet is working. Ping and dig resolving correctly tell you that routing and name resolution are functional. They tell you nothing about what's happening to HTTPS traffic. Always test with curl v https:/ against a known host before assuming the network is clean. Per account behavior differences eliminate the network as a suspect. When two accounts on the same machine behave differently with identical network configuration, the answer is in user space. Look at launch agents, look at running processes, look at anything that initializes per session. SSL connect. Connection reset by peer is a signature, not a mystery. When TCP connects successfully, and the reset happens specifically during the TLS handshake, a security product doing TLS inspection is the first thing to check. Not DNS, not your VPN, not your firewall rules. Check for AV software with a web shield or HTTPS scanning feature. Broken security software is worse than no security software. Avira in this state wasn't protecting anything. It was acting as a self-inflicted denial of service against every HTTPS connection on the machine while appearing to be a network hardware problem. High AP transmit power hurts weak antenna clients. Macmini's built-in antenna cannot match the output of an enterprise AP on high. The AP hears the client poorly, drops packets going uplink, and creates exactly the sporadic high-latency spikes that appeared here. Set transmit power to auto on any AP serving a Mac Mini. 3 problems were running simultaneously. The Pi-hole issue was real. The Wi-Fi asymmetry was real. The Avira TLS interception was real. They layered on each other in a way that made each fix look like it should have been sufficient, but wasn't. The only way through it was eliminating each layer completely before moving to the next. If your Mac can ping but HTTPS is broken, run curl v https://google.com first. The TLS handshake output will tell you more than any network diagnostic tool.